Bit of Flexvolt today, so can we fix this? So it's got no bars there on the indicator. Get the voltmeter on it and we're looking about 4.5. Now on the charger, doesn't even recognise it, and that's what you'd expect that low. Now if you haven't opened these before, there's screws all down the sides, so there's nothing underneath these, so not quite like some of the other brands. The sides pop off, and I'll show you in a minute what's behind it. So we'll just grab all of those screws, 4 on each side. There we go. Sped this up to ridiculous mode and pop it off. Now that came off really easy, and so did that, because this looks fairly brand new. A lot of the times these are pretty stiff to come off and you have to stick a screwdriver in there or wedge them off. Now looking at that though, there's no dust, there's nothing in here. This looks perfectly brand new, which is a little bit weird for it to be so low. Normally though, that means it's been on the shelf somewhere. Now these little ribbon boards, if you like, all come down from the board at the top. Now if you need access to the top, there's another couple of screws, but for this case we don't really at the minute. So we're just going to look at how high these cells are. Now whatever they are, they've got to equal 4.5, we know that already, and that one is pretty low. And you do see them sometimes that low if they've been left on a shelf for years normally. Now going around here, nothing is totally dead, but the first one was pretty low. If we can touch them, sometimes it's difficult actually to get right in there and touch the actual ends of the cells or the ends of the test points. Now going around, I think I had one that was good there, and the rest here are just stupidly low. Now what we'll do though, because it does look brand new, normally if this was old and kind of ruined, you'd say that these cells are just not going to come back. And with Flexvolt, it is a nightmare. But what we'll do is we'll at least attempt to bring these up. You'll see pretty fast though as you come round. As you start bringing them up, you get onto the next one, and the one you've just done normally drops. But again, I think in this case we might be lucky, but we'll give it a go. And that's what we do here. So this is how we fault find them, but certainly that would be the repair, and I'll show you some of that now. Now the way we do that is actually spot welding little test points on, so that you can get onto the edges. Some people have told me before they use magnets. There's many ways to do things, but this is how I do it. So just reminding ourselves that 4.5, not great. So we're going to now start some of that work on trying to bring this up. Now the first thing I'm going to do is a bit of a boost, a bit of a jump start, whatever you want to call it, but I'm doing that really to show you how that isn't a good idea. So if you were just to stick this on another battery, and I've seen many people doing that, even with Flexvolts, they don't really realise what they're doing and what the inside's made up of and how it's all connected. Just to show you, it's a terrible idea. Now you might be lucky if you do that and you get it working for a day or something like that, but the problem is what you're actually doing to the cells is pretty dangerous. So what I'm doing here is just connecting the board up at the top, and we're going not too high, but remember this was only at 4.5 volts. We're going to go a little bit higher, and then what I'll do is I'll look at some of the cells. Now if you remember some of the readings, they were all over the place, nothing was balanced or anything like that. One of them was actually up at 4 volts, so all you're going to do is max that one out and the rest won't come up. So if you stuck another battery on this, you're doing exactly the same as this. Just maxing that highest one out and not touching the others. Now look at that, that tells me this is full. But we know this isn't full, and it's done that because it's took that highest reading from that highest cell so that it can't overcharge it. So pretty stupid when you do those jump starts. So at least we've got one of the lights back on, which is good, but what we need to do is actually go around this pack now, find all of those cells that are low and bring them up. And you have to do it individually on Flexvolts. I still haven't really worked a way out where I can get a cable on all of these different sets and bring them all up together. Probably is a way, let me know if you've got one. Now this is what I do, I put these little nickel strips on, and it then allows me something to clip those croc clips on. Now again, some people say they use magnets and other stuff, but this is just how I do it. It's my preferred method. Everyone does their own thing, and this for me is pretty easy, but you just have to bear in mind the length of them and what they're touching. Don't want to cross them over with another set. Now a little bit of a different view for you, just a little bit close in to show you what I mean. I know sometimes it's difficult to see some of these angles. Now all I'm doing, as I say, popping that little bit on there, just giving it one little bang, and that is all I need. I just need something to connect to. Now here I'm just working out positive and negative sides so I can clip them on correctly. Negative on that side, positive there. And we use this little thing whenever we're doing these Flexvolts because we're looking at one cell at a time. This is how we do it. So we just then wait, and this can take a long time. So it can be an hour, it can be longer, it depends what I put the amps on. And then you just need to go around, basically find the next one, again find the polarity so we know which way that's going, get a little tag on it again. There we go, bend that one down, just because when I flip it over I don't want it touching the next set, because we'll get some sparks or some bangs there, so you don't want to do that. Now we're going to spot weld this back on then to that next little set of them, and these are very different to others, so they're not like your Milwaukee's or your Dewalt XRs, they're not in parallel rows if you like, they're just all over the place. Bit of a nightmare. You need a little map if you're actually putting these in, just to get them all the right polarity, the right way round, etc. Now here then, all I'm doing again is that next set. You could just do it all at once like this, go around, do all of those, and then just come back and hook it up. But for me that adds a little bit of risk if you like, because more of them could touch. So I'll do a couple at a time and then take the ones off that I've already done if they stay up. So other side, pop it on. And now that we've done this one, we will hook it up, and then after that one's done I normally go back and check the previous one. So if it's come down already, and sometimes, as I mentioned earlier on, with the older ones they do. So I just want to make sure that it's keeping it, otherwise I'm going right around the pack, taking hours and hours for no reason at all, because they just drop in behind me. So that's where we are, and again, check the polarity, which way we're going. And you can see that first set has actually stayed up, which is good. And then we need to make sure we get this on the right way around. And if you see my white little card thing there, I like to write the voltage on as well, so as I'm going round I can see it coming up or going down overall, and that's really helpful when you're doing the older packs. Right, so that's now on, so we'll get that hooked up and on in a second. And if you're doing this, I'd suggest don't stick these in the bin, would be my preference, but if you are doing it, just make sure that whenever you do that charging, make sure you've got it on that 1S. You don't want to have it overcharging, and these LiPro things, they just don't stop either, so it'll tell you it's full on the screen, but they just charge over and over, they go up and up. Gives you a little ring, a little beep if you like, which is good, but it doesn't actually stop. Now there we are then, so I'm updating that little voltage card in the bottom right, just to give me an idea of what's going on. And when you do it like this as well, you can actually rest your probes in here and watch your screen there on the bottom left, and the two values are actually different, so I'd go by the fluke, but the charger at the top gives you a little bit of a more vague answer if you like on the actual voltage, not as precise. Here we go. So now that we've got that done, we can then take another reading, see where we are. I'm taking these all the way up as far as they'll go, so about 4.2. They're going to drop a little bit, I think 4.18, something like that if we're lucky. I get the right one. There we go, and I've got the next one there lined up, ready to go. So we'll get that done, we'll get that hooked up. Let's just find the right spot. We'll spot weld that on. And it's just the same over and over and over again. There's lots and lots of cells in these Flexvolts, and this is one of the smaller ones, so you just got to be really careful as you're doing it, what you're touching, what you're not touching. These things are the most dangerous, I think. It's very easy to touch the wrong thing just because of the way they're all laid out there. Now again, all I'm doing here is getting that next little tab ready, and I'm going to spot weld it here, and then I can get that next one on. There we go. I only do it once because we want to be able to get that off, so I keep it fairly weak. I don't want to keep it on there so it can cause damage when I pull it off. So same on the other side. And let me know what you think of this view as well. I'm trying to do a bit of both. It's always difficult, that just top down, you kind of miss stuff. There we go, and that one was slightly off. That's why I got that bigger spark, because it wasn't quite touching. But there we go, all good. So that's that. So we're going to hook it up, and then we're going to go again. And you can just see how many sets of cells there are, how many individual cells, sorry. This is a very time-consuming thing. And especially if they just come down, it just becomes really annoying. So that's good. The first set stayed where they are, and we're now ready to stick this other one on. So make sure you get them the right way round. It does tell you actually, even this LiPo charger, it'll tell you you've got the polarity wrong. And then all you need to do is swap them round. Make sure it's not touching anything else. And I've put an extra one on there as well for when we're done, so it just makes the next one quicker. There we go. So that's what it looks like. That's it all hooked up. It looks simple, but it is pretty dangerous, as I say. Flexvolts in general are just a nightmare, and normally when you repair them, replace certain parts, they're just very unreliable long term. Normally best to buy a new one or rebuild the whole thing. Now that's what we do. Don't do these very often. Occasionally when people send me them by accident, I do them, or if someone has had a conversation with me and it's kind of a fairly simple thing, will help you out. But you can just see these are very time consuming and they're a bit of a nightmare. But that's how we do Flexvolts, and hopefully this one is repaired. I'll do a short probably on the outcome of it. But that's how we do it. Just wanted to show you how we do fault finding and the repair process.